There is a planet in our solar system that no human has ever seen. Not a blurry smudge, not a maybe, nothing. And yet a growing number of scientists will tell you with real confidence that it's out there right now, tracing a slow circle through the dark, farther from the sun than anything we've ever photographed. If they're right, it rewrites the map of our own solar system, the one you grew up believing was finished. If they're wrong, it's because the same trick that found a real planet once before just fooled some very smart people into chasing a ghost. Either way, the answer's coming. It's just a matter of when the sky finally gives it up. In 2016, two Caltech astronomers, Mike Brown and Konstantin Batygin, published a paper making the case for a hidden ninth planet, built entirely on math, not on a photograph. Brown had already helped demote Pluto once. Now he was proposing something to take its place. Something much bigger, much farther away, and much harder to prove. Here's the idea in plain terms. You can't always see a planet directly, but a large enough object leaves fingerprints. It tugs on everything nearby, bending and hurting the orbits of smaller bodies around it. Astronomers call these tugs perturbations. Think of it like knowing there's someone standing behind a curtain because you can see the fabric move, even though you never see the person. That's the entire premise behind Planet 9. Out past Neptune, in the icy debris field called the Kuiper Belt, a handful of small distant objects have orbits that shouldn't line up, and yet they do. Something massive, unseen, appears to be shepherding them into formation. This method has worked before, spectacularly. In the mid-1800s, astronomers noticed something wrong with Uranus. It kept drifting slightly off the path Newton's laws said it should follow, as if something out in the dark had a hand on it. In 1846, using nothing but pencil, paper, and gravitational math, astronomers predicted where an unseen planet had to be hiding. They pointed a telescope at that exact patch of sky, and Neptune was sitting there waiting for them. That should have settled the question of whether math alone could find a planet. It did, but it also planted an idea that would later go badly wrong. Neptune's discovery convinced astronomers that leftover wobbles in the outer solar system always meant a hidden world. So when Neptune itself seemed to wobble slightly, the hunt began again, for a Planet X tugging on it from beyond. In 1930, that search led Clyde Tombaugh to Pluto. But Pluto is tiny, far too small to budge a planet the size of Neptune. The wobble that supposedly proved Pluto's existence turned out, decades later, to be a measurement error in Neptune's mass, cleaned up once Voyager 2 flew past in 1989. Pluto was real. The reason astronomers went looking for it was not. That's the trap baked into this entire method. When you're hunting for a pattern in noisy, incomplete data, sometimes you find a pattern because it's real, and sometimes you find one because you were looking hard enough to see faces in the clouds. Astronomers have a name for that risk: observational bias. It would come back to haunt the Planet 9 story too. Which brings us back to Brown and Batygin. In 2016, they noticed something curious about a small group of distant Kuiper Belt objects, icy bodies orbiting far beyond Neptune. Their orbits weren't just similar. They were tilted in the same odd direction, pointed toward the same patch of sky, like compass needles all quietly agreeing on a direction that made no obvious sense. They ran computer simulations thousands of times, testing whether that alignment could just be chance. Later refined analysis by Brown and Batygin put the odds of the clustering being a random coincidence at roughly 1 in 500. But when they added a single hypothetical planet, several times Earth's mass, orbiting hundreds of times farther from the sun than we do, tilted about 16 degrees off the plane the other planets share, on an orbit that could take somewhere close to 15,000 years to complete, the simulated Kuiper Belt snapped into the same pattern seen in the real sky. That should have been the moment of triumph. It wasn't, quite. Because here's the uncomfortable echo of 1930. This pattern was found in a small, unevenly surveyed patch of sky. The same kind of limited bias data set that once sent astronomers chasing Pluto for the wrong reasons. Brown and Badigian knew that, and it's why they didn't stop at the first exciting result. They went back and built a method specifically to measure how much of the clustering could be explained by where telescopes simply happened to look. The bias was real, but even accounting for it, the alignment held. The pattern survived its own cross-examination. That's rare, and it's a big part of why the hypothesis is still standing years later. But surviving a check for bias is not the same as a photograph. Nobody has seen this planet. Nobody has confirmed what it actually is. And that's the part that should unsettle you. If Planet 9 exists, it might not even be a native of our solar system. Some models suggest it could be a rogue planet, wandering interstellar space, quietly captured by the sun's gravity billions of years ago. Others suggest it formed here, alongside Jupiter and Saturn, then got violently flung outward and never came back. We may be looking for a world that was born here, or one that was born somewhere else entirely and simply drifted into our gravity's reach. Think about what that means for a second. For all of human history, we assumed the solar system had a fixed number of planets, a finished shape. It didn't. Neptune wasn't there until math put it there. Pluto came and went as a planet within a single century, and now the outer dark may be hiding one more world, larger than Earth, so distant that sunlight reaching it is barely more than the starlight reaching us. So faint that even the largest telescopes on the planet have not been able to pick it out of the black. That may be about to change. The Vera C. Rubin Observatory in Chile began its 10-year all-sky survey in 2025, repeatedly scanning the entire southern sky, cataloging faint-moving objects with a level of detail no previous telescope could manage. If Planet 9 is out there and roughly where the models predict, some astronomers involved in the hunt believe Rubin could catch it within its first year or two of full operation. And if it doesn't, that won't necessarily mean Planet 9 isn't real. It could mean the planet is smaller, dimmer, or farther out than predicted. It could mean the true explanation is something stranger still. A handful of researchers have floated the possibility that the clustering could be caused not by a planet at all, but by a primordial black hole a few times Earth's mass, or even a subtle correction needed to our understanding of gravity itself. None of those alternatives has been ruled out. Somewhere out past everything we've ever photographed, something is quietly bending the paths of small icy worlds. And in the next few years, for the first time, we may finally get to see what it is.